everyone. In this video lecture, we learn about Murry loop test. So, first of all, what is Murry loop test and where it is used? What is the application of Murry loop test? So, as we know, in today's most of the power transmission is replaced from overhead transmission line to the underground cable system. So, if the power transmission is done by overhead lines and fault occurs, then it's very easy to find out the fault location and replace it. But what happens when fault occurs in underground cable system? It's very difficult to find out the fault location and repair it. So here we use an Murry loop test to find out the fault location in underground cable system. Here we show how to test and how to find the fault location. Now assume we have an underground cable system and fault occurs at the X meter away from the one end of the system. So how to find the fault location? What we required to conduct this test? First of all, we required an one sound cable which is connected to the parallel of this faulty cable. And now what we required? Second, we required an very low resistance which is connected between the two ends of the cable. So after that we start and test with some requirements. So what we want to do? Here we show an circuit diagram of this test. In this test, what we required? We show here an underground cable. We show here the fault occurs at X meter away from the one end of the system. So we need to find out that X meter and find the fault location. So how we can detect it and how we can calculate the X meter? So simply we connect an one sound cable shows here parallel to this faulty cable. So simply we connect an one sound cable parallel to the faulty cable. Now what we do? We required an two resistors, resistor A and resistor B, and one galvanometer which is connection as per the circuit, and we also required an one battery supply. So now what we do? This is an circuit diagram for the conducting and the test. Now we go to the next step. Now after arrangement of the circuit, what we do? We need to adjust the value of both resistors A and B in both arms. We connect and two resistors A and B and need to change the value of that resistance. So we change the value of that resistance until the reading of galvanometer becomes to 0. When we galvanometer indicates an 0 indication, then it means that circuit becomes an balanced circuit. Now what we do? We simply note down the value of resistors A and resistor B, which is useful in further steps. In this circuit, we show what we do. We connect an resistor A, resistor B and galvanometer. When we start apply an battery power supply, then galvanometer indicates something value. This value indicates that it's an unbalanced circuit. So what we do? We simply change the resistance of A and resistance of B according to the galvanometer indication. After galvanometer indicates an 0 value, means it will detect an null, then we simply note down the value of resistor A and note down the value of resistance B at some place. Now in next step, what we do? So when our circuit is balanced, it works as Watson bridge circuit and it becomes an Watson bridge circuit. So we show our circuit as a Watson bridge circuit in which two resistors A and B are 1 and 2 arm, the good conductor means and sound conductor, and the faulty conductor, in which resistor X and resistor R are the faulty conductor resistors and RJ is the good conductor resistors. Now in this the third arm is not only Rg but it's an Rg plus R, and the fourth arm is X, which we require to find out. If we find out the value of X, then we can find out the value of the resistance, and from it we can find out the distance from the operating point to faulty point. So here we shows an Watson-Bridge circuit equation in which we shows an equation in the four arms. A by B is equal to R by X. Here R is the Rg plus resistor of the faulty cable in which other side. So by simplification of it, we get an A by B plus 1 is equal to R by X plus 1. Further simplification, we get A plus B by B is equal to R plus X by R, in which we need to find out the value of X. So how we can find out the value of X? Here in first setup, we set the value of A and value of B. Among them, value of A, B and by B we can find out, simplify it. So we need to just find out the value of X. If we find out the value of X, then we can get the value of X. So what is R plus X? R plus X is the total resistance of the sound cable and faulty cable. We know the resistance of sound cable and total resistance of faulty cable by the manufacturing companies, by the data sheet of that cable. So we have a total resistance of R and total resistance of X, and the value of AB are noted down in the first step of this test. So simplifying it and putting the value in the equations, we can simply find out the value of X in the term of resistance, which shows an resistance between the operating point and faulty point in the cable. So from the value of X in terms of resistance, we can simply convert it into an distance by an ratio trick. In this, we convert an S is denotes an resistance in terms of total resistance, and we can find out its distance. From circuit and equation, we show how we can find out the value of X. Here, resistor A and resistor B, which we set the value of A and B as per the galvanometer. So it's an determinant. So now we want to value of X and X plus R. Here R is the conducting wire or sound cable which we connect parallel to the faulty cable. So value of resistance of the good conductor or sound cable, it's determined by the manufacturer provided in data sheet. So now in faulty cable conductor, we know the total resistance of faulty cable conductor using the data sheet of the conductor. So R plus X is the total resistance of good conductor plus faulty conductor. So the R plus X value is determined by the manufacturer data sheet. Now the last term is X. We can simplify the equation from this and determine the value of the X. X is the total resistance of the faulty point to the operating point. So we need to convert that resistance into distance. So how we can convert from the resistance to the distance? In next slide we show it. Now in this slide we shows how to convert an resistance into distance. Suppose X is the 10 and resistance R is the 90. So X is the 10% of the total resistance. So simplify it, we have a total distance of 100 km, then the distance of the operating point to faulty point is 10 km. If the distance is 1000 km, then the total distance of operating point to faulty point is 100 km. So among them, we can find out the total value of X and convert it into the distance of the faulty point. So From this video lecture, we learn about Murry loop test to find out the faulty point location in underground cable system.